Assalamu alaikum, dear students of second year class. In our last lectures before the winter vacation, I have completed chapter of phenols, alcohols. Now today I am going to start a new chapter, that is aldehyde and the ketone. First of all, we are focusing on the chapters of organic compounds. So what is the aldehyde and ketone? Aldehyde and ketones are the organic compounds. They are also called as the carbonyl compounds. Why they are called as the carbonyl compounds? Because this C double bond O, look at this slide, double bond O is basically, C double bond O is called as the carbonyl. So in any organic compound where the C double bond O is used as a functional group, that is called as the carbonyl compounds. Now what are the organic compounds that comes in this category of carbonyl compounds? Any organic compounds containing the C double bond, I am going to repeat this, any organic compound which contains the C double bond O as a functional group is called as a carbonyl compounds. Now two types of the compound we are going to start, aldehyde and the ketone, both of them having the C double bond O as a functional group. So we can say aldehyde and ketones as are carbonyl compounds, carbonyl compounds, if you look at this, C double bond O, carbon bond is bonded with the oxygen with the double bonds, one sigma bond and one pi bond. That is very important. First of all, I am going to discuss before going to my chapter aldehyde and ketone, first of all I am telling you about the carbonyl compound. So why the carbonyl compounds are very important? Because look at this picture, look at this, here is the C double bond O. C is bonded with oxygen with a double bond. Oxygen, is more electronegative, so it withdraws the electron towards itself. When it withdraws all the electron towards itself, it carries the negative charge, and carbon partial negative charge, and carbon almost contains the positive charge. So a polarity develops due to the difference of electronegativity. In my last lecture, so many times I have told you this phenomena. So I am going to repeat today. Here is the two bonds. Oxygen is more electronegative than the carbon, so it withdraws the electron towards itself and carries the negative charge. Oxygen carries the negative charge and carbon carries the positive charge. So a polarity develops. That is the carbon oxygen double bond is polarized, which you can say it's a polarity develop, induces the polarity, and both of them, carbon carries the positive charge and oxygen carries the negative charge. In my last lecture, nucleophilic substitution reaction or SN reactions, I have explained the terms electrophile, nucleophile, nucleus loving, so it carries the negative charge. So here oxygen behaves as a nucleophile because it carries the negative charge, and carbon is here electrophilic center because it carries the positive charge. So these two terms can also use in the carbonyl compounds due to the difference of charges. A polarity develops. Due to the polarity develops, oxygen carries negative charge, carbon carries positive charge. One end is the nucleophilic center, that is the oxygen, and other end is carbon is electrophilic center, and the reaction follows both of them. Okay, this is all about the carbonyl compounds. Now, which compounds comes in category of carbonyl compounds? Aldehyde and the ketones. Aldehyde and ketone, both of them are the organic compounds which contains the carbonyl carbon atom. Look at this, C double bond O as a functional group is called as the carbonyl compounds, aldehyde. Now, how do you differentiate the aldehyde ketone? If the two ends are there, C double bond O is in the center and one end is R, other end is hydrogen. If one that is shown in the red color, so if the one side is fixed with the hydrogen atom C double bond O H and other side is the R, you know, alkyl group. So what is the aldehyde? If the one side of C double bond O carbonyl compound is attached with at least one hydrogen atom, it is called as the aldehyde. And other side is the alkyl group, which may be alkyl, aryl. Alkyl, I have already told you about the alkyl, propyl and all the list we have learned. Now this is the structure of aldehyde. This is the structure of aldehyde. And if the both sides of carbon is attached with the R, alkyl groups, then it is called as the ketone. R, hydrogen is replaced by the R, so it is called as the ketones. Aldehyde and ketones shows that type of the structure. Here I am going to discuss the nomenclature of aldehyde. That is very easy. Nomenclature, first of all, you already know, nomenclature is two types, common names and the IUPAC name, right? How do you write the IUPAC name? In the last chapters, I hope you understand the phenomena of IUPAC or rules of IUPAC system. So here I am going to discuss briefly. For example, first of all, what are the rules? First rule, select the longest carbon chain. Select the longest carbon chain. Second is functional group. Second is functional group is included with the parent carbon chain. Second is always gives the lowest possible number. I have repeated the rules. First rule, always first rule is always there, select the longest carbon chain. Second, check your functional group at this. Third, assign the lowest possible number to the functional group. Fourth is how many methyl groups or alkyl group as substituents are present, assign them. If more than two substituents are present, you can say di, tri. One thing is also very important by writing the name of aldehyde according to the IUPAC name, it is derived from the alkane. For example, here alkane is pentane, ethane, propane, butane, pentane. So in the aldehyde, if the E and pentane, you have to derive the IUPAC name of aldehyde from the pentane, from the alkane. So 4 rule I have already repeated. Now fifth one is E is replaced by, how do you write the name of aldehyde? E is replaced by the Al, that shows the aldehyde, pentanal. Right, here is the simple example I have quoted. For example, first of all, select the longest chain 1, 2, 3, 4, 5. Longest chain is the 5 carbon atom, so you have to decide the parent chain is the pentane. Second, always gives preference to your functional group. Here functional group of the aldehyde is the C double bond O. So always assign the lowest possible number to the C double bond O. Here I have assigned the 1. So third is the if there is any substituents, here is the ethyl CH2 CH3. Now, right, how do you write the name? Name the parent chain by replacing the E with the Al. And how do you write the name? Very simple. Determine the identity and the look at. 3 things are very important. Parent chain, prefix, that is a functional group, and the suffix, that is the alkyl group or substituents. So how do you write the name? Very simple, 2-ethyl pentanol. One thing is very important, E is replaced by the Al. E is replaced by the very simple Al. Another, there is other example I have written here. For example, you look at this, 2, 1, 2, 3, 2-methyl propane. E is replaced by the Al, propanol. If there is any other functional group, Cl, dichloro butanol. So this is very simple. Three things keep in your mind. First, parent chain. Second, prefix, that is functional groups. Alkene, alkyne, alkane, RX, and here we have aldehyde. So third, suffix, any alkyl group as a substituent. And third, naming, you have to derive your name of aldehyde from the alkane. This is all about the IUPAC naming of the aldehydes. And if there is aldehyde common names for simple aldehydes, you can use. Generally we have derived the common names. If there is both of sides of carbonyl compounds is covered with the 2 hydrogen atom, that is commonly called as the formaldehyde. If one side is with the alkyl methyl group, acetaldehyde. If 2 carbon compound or ethyl group is present, propanaldehyde. These are the commonly used name of the aldehydes. The nomenclature. Nomenclature is also very important. Okay, now next go to the preparation of the aldehyde. How do you prepare? Very simple. Aldehydes can be produced, can be prepared in the laboratory by the oxidation of the, that is very important, by the oxidation of the primary alcohol. By oxidation of the primary alcohol. If you use the primary alcohol, formaldehyde is formed. So what type of the conditions and reagents are used for the oxidation of the aldehyde? Oxidation of aldehyde, in the case of the aldehyde and the ketone, something is different. When the reaction is used for the aldehyde preparation, that is very important. Always try to understand, if alcohol is going undergo the oxidation, for example, if the oxidation of primary alcohol takes place, aldehyde are produced. If the oxidation of secondary alcohols takes place, then the ketones are formed. How do both of the ketone and the aldehyde are produced? By the oxidation of alcohol. If there is a primary alcohol, aldehyde is produced. If there is a secondary alcohol, ketone is produced. So keep in your mind. Now the question raises, first of all, I have used here primary alcohol which undergo the oxidation and give rise the aldehyde. But the reaction condition is very important point to be noted. When this reaction is used for the aldehyde preparation, reaction condition must be sufficiently mild to avoid the further oxidation. If there is no mild conditions of the potassium dichromate, KMnO4, and so many oxidizing agents can be used at a 300 temperature, then what happened? Very simple, this aldehyde is converted further into the carboxylic acid. Further oxidation of aldehyde takes place. It is possible. Aldehyde undergo the further oxidation if you are not using the mild conditions of the reagents. So carboxylase. So if you have to prepare the aldehyde, mild conditions and mild oxidizing agents are used. So primary alcohols is converted into the aldehyde. Okay. If here is formation of the preparation of the formaldehyde. What is the formaldehyde? Before going to preparation, you know, C double bond O, H, H. Both sides of the carbonyl compound is covered with the 2 hydrogen atom, that is called as the commonly called as the formaldehyde. How is it prepared? In the laboratory, we have to use the methyl alcohol. Oxidation takes place. Platinum catalyst at the 300 temperature, it is converted into the formaldehyde. What happened? You are using the flask, right? And when the methyl alcohol is, first of all, methyl alcohol is taken in the round bottom flask. Air is extracted. Air is removed from the round bottom flask by the suction pump, and easily filled methyl alcohol is converted into the formaldehyde, which is in the gaseous state. That point is very important to understand how the formaldehyde is produced, my dears. Methyl alcohol is undergo the oxidation, forming the gaseous formaldehyde. In the container, in the receiving container, you have to take the water, and this gaseous formaldehyde absorbed in the water. And this mixture of water and the formaldehyde is commonly used, called as the formalin. Formalin is present in the lab. Its most important use is for the preservations in the biological lab. So formalin is very important. So what happened? The gaseous formaldehyde is absorbed in the water, and this mixture of the formaldehyde and the water is called as the formalin. Formalin contains the, I think, 40% formaldehyde and 50% water. That is called as the formalin. In your short questions, in your exams point of view, question always ask the question, what is the formalin? Formalin is basically the mixture of formaldehyde and the water. It 40% formaldehyde, 52% water, and some methyl alcohol, 8%, 7% methyl. That is called the formaldehyde. Now come to the next preparation of acetaldehyde. First of all, what is the acetaldehyde? If the C double bond O, one side is directly attached to the hydrogen atom, that is fixed for the aldehyde. Other side is replaced by the hydrogen from the formaldehyde to the R group. If there is a R group, so how that is called as the, commonly called the acetaldehyde, right? Acetaldehyde. How is it prepared? Acetaldehyde, look at this. Ethyl alcohol over silver catalyst at the temperature of 500 undergo the oxidation, form the methanol or acetaldehyde is formed. What type of aldehyde is formed here? Acetaldehyde formed. Look at this. This is the apparatus used for the preparation of the acetaldehyde. What type of chemicals are used? Primary alcohol. Here I am going to, in the case of methyl alcohol use, here ethyl alcohol is used for the preparation of acetaldehyde. Undergo the oxidation, silver catalyst, and all the catalyst and the 500 temperature. In this round bottom flask, a mixture of ethyl alcohol and sodium dichromate solution, that is used as an oxidizing agent, and the sulfuric acid, run and the boil, right? Run and the boil. Immediately acetaldehyde is formed, and acetaldehyde is formed in the liquid and attached in the receiving flask and distilled it. If you are not allowed and take out this acetaldehyde as soon as possible, it is converted into the carboxylic acid. One thing is, oxidation of acetaldehyde takes place, that form the carboxylic acid. Here carboxylic acid is acetic acid. Ethyl alcohol remains in the solution until pure acetaldehyde is obtained. If there is a present some ethyl alcohol, redistillation takes place and pure acetaldehyde can easily prepared. This is my first lecture of this chapter, aldehyde and ketone. I have discussed what is the carbonyl compounds, what is the aldehyde and ketone, and nomenclature of aldehyde, and prepare the aldehyde in the laboratory. Inshallah, in my next lecture, I will explain the reactions of the aldehyde and the ketone. Thank you.